Okay, so my name is João Pereira. I'm a backend engineer on the package team at GitLab. I work with the Container Registry, and we are recording this session so that we can give an explanation about the registry data structure and how images are stored on the file system. And we will also see how that correlates with the GitLab UI and information that we see on the GitLab UI. Nordin, I don't know if you want to introduce yourself.
Yeah, I'm Nordin. I work at GitLab as well. I'm in the support team. And whilst investigating a ticket for a customer, I came up into this topic and Jao offered to show it around.
Okay, so the setup that I have here is built with using GDK, so anyone can reproduce what we are going to do here. If you don't have GDK set up, you can do so following the instructions on the official repository. And it's also necessary to do the setup for the registry, which you will also find the instructions on the repository. Okay, so just follow the instructions to set up and then the instructions to turn on the registry as well. Then we are going to use a sample project which comes with the GDK, and that's the GitLab test project inside the GitLab organization. We can see that right now there are no images on this registry. So what we are going to do is build some images for this and see how that appears on the file system for the registry, and then see what information we can correlate between the file system and the GitLab UI. So we can see the status of my GDK here, just to confirm everything is okay. Everything is okay. We can see that the container registry is up and running. So the first thing that we need to do is log in. The default user for the GDK is root. You can use either a password or an access token. I have an access token here, so I'm going to use that. We are done. And now the first thing that we are going to do is look at a really simple Docker file that I have here. So let's see. So this is a Docker file that inherits from Alpine version 3.11.6. And the only thing that it does is basically echoing the hello world string. So this is a really simple test. So let's build an image based on this. And let's call it version 1.0.0. Okay, I'm going to use the test repository that I just mentioned it. Okay, let's test the image. Okay, it does what it should do. And now we can go ahead and push the image to the container registry in GitLab. Okay, now GDK stores the registry data in its root folder inside the registry storage. Okay, so inside this folder you have all the data structures that are saved by the container registry. So everything is inside here. We can see its size right now. So at the moment it's 2.7 megabytes. So that's pretty small. We can also see that I have the file system of the registry open here on VS Code. We can see everything that it's inside. And the container registry always has this structure. So a folder with Docker, another one with registry, then V2, and then we have two main folders, which are repositories and blobs. We will look first at repositories, okay? So as you saw, we have, let me switch back here. We have used the gitlab.org, gitlab.test repository. So we have a folder for gitlab.org here. Then we have a folder for gitlab test here, okay? And then inside, we have the contents of the repository, okay? We have three main folders here: layers, manifests, and uploads. Let's ignore uploads because they are not meaningful for now, but basically this is a local cache that is used to cache multi-part uploads. We don't need this for this video. The main one that we need to look at is the manifests folder. And as a brief explanation, in Docker, we have repositories, we have images, and we have tags, okay? So the repository is GitLab org, GitLab test. And then we have a tag now, which is 1.0.0. And basically the repository with the tag corresponds with an image, okay? So when you want to create a container or run a container based on an image, you always need the repository and the tag, and that gives you an image. So on the Docker file system, on the Docker registry file system, there is not a single file that represents the image. You only have a folder for your repository, and inside that folder, you have one or many tags, okay? So then we also have another thing which is called a manifest, and the manifest is basically a recipe to build an image for that repository and that tag. If you look here on the text folder, we have tag 1.0.0, and if we see current link, we can ignore index for this video, but if you look at the current manifest that this tag points to, we will see a digest, okay? And basically this will tell us, okay, to build an image for this repository and this tag, you should follow the recipe that is written in the manifest that has this digest, okay? And basically inside the registry, everything is referred by digest. Digest is like the primary key for everything inside the registry, okay? Now, you may ask, okay, if you only have this inside the repository, where are the image, right? Where is the content of the image? So an image is composed by layers. If we look at the image that we just built with the Docker history command, we can see that this image has a layer with data, okay? And then we have also two entries here with no size. This one comes from the base Alpine image. Okay, so we haven't done anything about that. If you look at Docker Hub and you look at this image, you will see that we already have here the command to run the image. So that's not ours. The only thing that we added to the image is this instruction here, okay? So we are not actually adding any more data to the image. We are just overriding the command to start the image. So if we look now at the manifest, let's grab this digest and go to the blobs folder. And then we are going to find the digest that we are looking for. So F662, it's here, okay? So this is the image, this is the manifest for the image, right? Tag 1.0.0 inside the GitLab org, GitLab text repository as this manifest, and this manifest tells Docker how to build an image format, okay? Inside here, we have two main components. We have a configuration, which is also referred through a digest. And the configuration, if we look for it, it's also stored in the blobs folder, and it's another JSON document that you can look at. Let me just set this as JSON and reformat. Okay, and the configuration is the document that will tell Docker how to build a container based on this image. So it includes stuff like the command. It will tell Docker about the platform that this image can run on. It will tell Docker the history of the image. So basically every single thing that we did to build the image is here, and the operating system as well. So this is only interpreted by the Docker engine. We don't need to worry about it. So if we go back to the manifest, we have the configuration, and then we have the layers, okay? And the layers are basically what compose an image. So an image can have many layers. For each modification that you do, you create a new layer. In this case, we didn't do any data modifications, right? The only layer that the image will have is the Docker Alpine layer, okay? Because the only thing that we did was override the command, and that has no data effects. So the only layer here comes from the Alpine image. And we can also find it inside the blobs folder. So if we look by this digest inside the blobs folder, we will find it. So CB, here it is. And this is a binary file because it is compressed, okay? But this is basically the real layer for the image is stored here, okay? Now if we look, let's look again at the manifest. We have the size of the layer, right? And this is the compressed size. And we also have the digest. So let's look at the GitLab UI. Refresh. And we can see that we have a repository here. And if we go inside, we have one tag. That's right. It has an image ID, and we can see the compressed size here. So this is correct. And this image ID that you see here will match the ID of the configuration. So if we look here, it's the same thing. It's the first portion of the digest of the image configuration. Okay. So now if we look at the registry size, and this is the part that may become confusing, we have 2.7 megabytes. Now let's say I want to push another image. It's also based on the same Docker file, but it will be hosted in a sub-repository, okay? So let's build this and let's put this inside a sub-repository this time. Okay. GitLab allows sub-repositories, so you can do this. Now let's push the image. It's done, and let's go back and check the registry size again. Okay, so it's the same thing, right? We have pushed one image, we have pushed the second image right now, but the size is the same. So some could expect to see double the size because we have pushed 2 images, but in the end, they are exactly the same thing. So if we come to the full folder inside GitLab.test, this is our sub-repository. If we go and find our tag, we will see that it points exactly to the same manifest as the other one. So let's go back here to the root repository. Same thing, right? So one thing to keep in mind is that the registry doesn't store any duplicates. So if an image references the same layer, it won't store the layer twice. It will store the layer only once, and the same goes for the manifests. If you have an image that exactly equal but have a different tag or are in a different repository, the registry won't store 2 copies of the same manifest. It will only store 1 copy, and that's why the only thing that we have inside the repositories folder are links, okay? And these links will basically work as an hyperlink for the web, but here for the registry, they work as a link to the actual manifests and the actual layers and configurations that we have inside the repository. So as we can see here in the blobs folder, we have exactly the same things. There are no more entries because we pushed the image to a different repository this time. So it's the same manifest. The manifest hasn't changed. It has exactly the same configuration because we didn't change the image. We just created a copy of it in a different repository. And that is only a single layer as well, okay? Now, if we go back to the UI again, we can see that we still have a single image here, and this one has 2.68 megabytes with this ID. And then if we go to this one, that is also a 1.0.0 image, which has the same size and the same ID. So looking at the UI, you may think, okay, my registry right now has this size multiplied by 2, but it's not the case because they both reference the same image ID, so they only exist once on the backend. Okay. So now let's try something different, and that is modifying our sample Docker file, and now let's actually trigger the creation of a new layer. So to do that, right now we are just echoing the hello world string. Let's go ahead and instead of echoing the string, let's first write the string to a file. I'll name it hello. And here, instead of echoing the string, we are going to get the file, okay? The result will be exactly the same, the output will be exactly the same, but now we are actually creating data on this Docker file, which means the Docker daemon will create a new layer which will contain this hello world string inside the hello file, okay? So let's go ahead and call this version 2.0 of our dummy application. Let's make sure it works. 2.0. Yeah, exactly the same output. Now let's go ahead and push this new tag to our repository. Okay, we already saw that something changed here. Okay, so this time we have more blobs in our file system. Let's first look at the repository. Let's ignore this one and this one. Let's look at the new folder, which is here for tag 2.0.0, and let's see what manifest does it point to. So it's not the same manifest than tag 1.0, right? So this one was F66, and now it's 99F. So it's a different manifest. Why? Because we have changed the receipt of the image, we have changed the image, we have added new data. So the receipt to build the image, it's also different. And so is the configuration. And therefore there is a new layer for sure for it. So let's first look at the manifest. Let's go to the blobs folder. Let's find our new manifest. Okay, and we can see here that we have a different configuration as well. So we did more stuff on this Docker file. And if you're going to look after the configuration, let's change this to JSON format. Okay, you can see already that we have a different comment here. And if we look at the history, we can also see that right now we also have a new instruction here, which will lead to some new data. So we need a new configuration file, that's fine. Let's go back to the manifest. And now, instead of a single layer, you probably remember on tag 1.0.0, we only had one layer, and it was this one, right? This time we are using the same image, but we are extending it with an additional data, right? So on top of the existing layer, we added a new one. And this new one is basically our hello file with the hello world string. That's why it is so small. And it has this digest. So if we go and look for it, there is a folder for it, and it's here. Our layer, it's here. This means that whenever you pull the image 2.0.0, what Docker will do is first it will look to see if the repository and the tag exists on the container registry. Then it will grab the manifest for that image. We already saw that. Is this one. Then with the manifest in hand, it will pull the configuration, okay? And it will pull all the layers that it needs to build an image following this receipt, okay? So the most important part here is not looking at an image as a single file in the container registry, because that doesn't exist. In the container registry, we only have the layers that compose an image, and we have the receipts to assemble those layers in order to build the image, okay? So that's the most important concept that we should keep in mind. So let's look again at the repository. And now we have tag 1.0.0, tag 2.0.0. They have the same size. We only added a string to a small file, so that's not an issue. But now they have different image IDs, right? So looking at this, we could say, okay, the size of this repository is this with this, right? Because we have two tags and they have different image IDs. So for sure, the size of my repository should be around 5 megabytes. So let's see if that's true. So remember, we had 2.7. Now, if you look at it again, we only have 2.8. So we don't have twice the size. We have 2.8, which is exactly what we had before, plus the layer, the only layer that we actually created and the registry didn't have before. Okay, so this is why it is difficult to estimate the size of a repository, because the repository may be reusing some layers that are either belonging to the same repository or belonging to a different repository. So let's say that after this, we would create a new project, GitLab test2, and we would repeat exactly the same steps that we did here. It wouldn't duplicate the layers, right? Because the layers already exist. It will only create links for those layers. So in the end, the repository would have exactly the same size, but now we have more repositories, okay? So this is the part that can be confusing, but the most important thing to keep in mind is that images are just a bunch of layers, and in the registry, we have those layers and we have the receipt to assemble them, okay? So Nurdin, do you have any question, anything that pops up after seeing this?
No, this is actually quite clear. So it starts with a manifest that points to the data, right? To what
Yeah.
and then it shows what layers it's made up of.
Exactly.
And then each of that layer is basically a blob, and the sum of all those blobs is how large your registry is.
Yeah. And those blobs are shared not only within the same repository, but they can be shared across repositories. So let's say, for example, imagine that in GitLab, everyone would use the Alpine as the base image, and we have 100 repositories. We wouldn't have 100 copies of the layers of the Alpine image. We would only have one copy, and every single repository will reference that layer, okay?
Okay.
So
can you humor me
yeah.
and clear the registry storage? And then basically the first example that you took from Alpine, that as a single line in a Docker file, and then build that.
Yeah.
Is that something that you want to try out now, or did you want to follow up on where you are at now?
That's basically the first version that we did, right? So we have you can do this. Basically, what you were suggesting is don't change anything on the image. Is that it?
Yeah, and in my case, when I did this, I ended up with a registry that was very small. It was smaller than 2.7.
Yeah, it depends on the version you were using. I pinned a specific version here. It depends. The size will vary between versions. Another thing to keep in mind is that here we are talking about the compressed size. So the registry only stores the compressed version of the layers, and the size that the registry tells you about is the compressed version. But when you pull an image from the registry with Docker, it will decompress those layers, okay? So if you look at the size on your machine and the size on the registry, they won't match, right? Because the registry saves the compressed version, and in your local machine, you may have a decompressed version. So the size may not match. So one of the things that we also discussed was how to estimate the size of a repository. Okay, so we can do that. You can do that through the UI. but that doesn't account for duplicated blobs, right? So looking at the UI to estimate the size of a repository is not feasible. At the moment, we don't have any tooling to scan the registry file system and identify the real size of a repository. You could do it like we did here. So for example, inside the repository, we have two tags, but we know that they point to the same base layer. We could, instead of looking to the manifest folder, we could look at the layers folder, and the layers folder basically has a link for all layers that are used inside the repository. Okay. And this also includes the configuration file, which is usually the first one. But if we ignore that, we could, for example, if we want to know the size that a repository is occupying, we could look at every single layer, either by looking at the manifests or come here, which is basically just the shortcuts. And then we would find the size of each one of these blobs. We would sum them, and that will give us the size of the repository. Okay. The only thing to keep in mind is that the size that it takes, theoretically, it's probably not the size that it will take on the file system, because you may have other repositories that share the same layers. So as we saw here, although our GitLab test had 2.7 megabytes, and then we copied it to the full repository, and it also had 2.7 megabytes. That doesn't mean that both of them are taking 2.7 megabytes, right? We saw that. They are not taking that. They are taking much less than that because they share a lot of data.
So the key would be to identify all those layers and then just take the sum of those layers, but not counting them twice for multiple times when they come across different repositories.
Yeah. So if someone is looking for saving space, say they have a big registry and they have a lot of images that they don't need to keep, they could do something like that to identify the repositories that hold most of the big images, and then see if they can save space by looking at the layer size. But one thing that we also need to stress out is that what the registry does, for example, when doing garbage collection, it will basically walk through each one of these folders, and we'll look at each one of the blobs and see, is there some repository that references this blob? Does any repository need this blob? And if someone needs that blob won't be deleted, won't be garbage collected. It will only be garbage collected if there are no links in any repository for that blob. Okay. So, for example, we have created this tag, right? And here we have added a new layer. So let's see again, version 9.9. This was the layer that we added, right? This is unique to this tag inside this repository. So if we delete this tag, let's say, of course you wouldn't do. Let's actually do it through the UI. Let's delete this tag. Okay. Remember to run garbage collection to remove the stale data from the storage. Okay, this is a nice warning. This means that right now, whenever we run garbage collection, the registry will find out that there are no other repositories referencing this layer, so it can be safely deleted, because the only one that was referencing that was the tag 2.0.0. We deleted it, which means that no one else is using it, so it's safe to remove it. Okay.
Okay, so the garbage collection goes through the blobs, looks at all the layers that are addressed, and if it can't find it in the repositories, it deletes itself. It deletes the blob.
Deletes the blob. So yeah, so that's basically a two-phase scan. First, it will scan every single repository, it will save the reference or the digest of every single layer that is referenced across all repositories, and then it will do a second pass over the blobs folder and will delete everything that is not on that list of digests to keep. Okay. Do you have any other questions that you think might be useful?
No, this was actually pretty cool. I will try to redo what you just showed me by myself, so I can retain the information better.
Yeah, that's
Looks
fine.
pretty clear now.
Okay, so I think that's all. Thanks for your time. It was nice to meet you. Bye-bye.